Hello and welcome back. This is part 3 of solving basic equations. Basically, part 1 was about solving basic equations using addition and subtraction. Part 2 was basically about solving basic equations using multiplication and division. This is part 3 where we combined all of them. So basically we are solving for x using multiplication and division and addition and subtraction. Okay, so we have a set of examples here and I am just going to apply everything that we have learned. So we have 2x plus 1 is equal to 3. We want to isolate x. So what I'm going to do is I am going to subtract 1 from both sides and we are left with 2x is equal to 3 minus 1, right? Because 1 minus 1 is just 0. So now we have 2x on the left side of the equation and 3 minus 1 on the right side of the equation. So now I'm just going to take it a step further. 3 minus 1 is 2. And now we are going to divide both sides by 2. So the 2's cancel here and we are left with x is equal to 1. Okay? There we have it for our first example. Let's look at our second example. Again, we want to isolate x. We have a subtraction sign. So we are going to add 4 to both sides. So I'm going to say 2/3 x is equal to 7 plus 4. So if I add 4 to this negative 4, we get 0. That's why we're left with 2/3 x on the left side and 7 plus 4 on the right side. Again, we have 2/3 x is equal to 7, 8, 9, 10, 11. Okay? And so now we have a fraction here. Be careful. So I left the link to the description in the description for part 1 and part 2. So we have a situation like this. So what I'm going to do to avoid any errors is I'm going to go ahead and give 11 a denominator of 1. So now I'm going to isolate x by multiplying by the reciprocal. The reciprocal of 2/3 is 3/2. So I'm going to multiply this side by 3/2. So now we're left with x is equal to, by the way, since we are multiplying by the reciprocal here, the 3's cancel, the 2's cancel, and we're left with just 1x. So now I'm going to multiply the numerator, which is 11 times 3. And I'm going to multiply the denominator, which is 1 times 2. And now we're left with 33/2. Now this is an improper fraction, so you are welcome to convert it into a mixed number if your teacher asks you to do that. I had my students to convert it into a mixed number. So if you need a refresher on how to do that, I'll leave the link in the description so you can refresh in your memory. But for now, that's not our subject, so we'll leave it like this for now. Okay, so let's come over here. Again, I'm just going to rewrite 5, 6x, and we have a plus 2, so we're going to subtract 2 from both sides. By the way, be careful here. We're dealing with a bunch of fractions, so why don't I go ahead and make this one a fraction? 2/1 is just 2, so just to avoid any errors, this is what I like to do. So if I subtract 2/1 from both sides, then we can have negative 5/6x by itself on the left side of the equation. So now we have 3/4 minus 2/1. So now we need a common denominator. So common denominator for this is a 4. And again, you need to refresh your memory on adding and subtracting fractions. I'll leave the link in this description below for that. Okay, so there's a lot of things. I did my videos in sequences so that you can, build on the math skills. Okay, so our common denominator is a 4. So in order to do that, I need to multiply the top and the bottom by 4. So 5/6x is equal to 3 over 4 minus 4 times 2 all over 4 times 1. Okay, and so now we have 5 over 6x is equal to 3 over 4 minus 8 over 4. And now we can combine our numerator. So now we have 3 minus 8 all over 4. 5 over 6x is equal to 8, 7, 6, 5. That'll be a negative 5 over 4. Okay, so now we're done with the adding and the subtracting part. So now we still need to isolate x. So to isolate x, we need to multiply by the reciprocal. The reciprocal of negative 5 over 6 is negative 6 over 5. And I'm going to come over here and write negative 6 over 5. And now we're left with x by itself. A negative times a negative is a positive. And we have negative 5 times 6 is a positive 30. And 4 times 5 is a positive 20. We can reduce this, can't we? So how about I divide the numerator by a 10 and the denominator by a 10, then we are left with 3 over 2. Again, this is an improper fraction. You can convert it to a mixed number. Also, I have a video on how to reduce to lowest terms. I'll also leave that in the description box. So, okay, let's look at our last example, and then we'll just have like 2 more after this. We need to isolate x. So I'm going to run through this really fast. 7/3 x is equal to negative 2 over 3 plus 5 over 2. And why are we doing that? Because we have a negative sign, so we need to add both sides by 5 over 2. So now, what is our common denominator? Our common denominator is a 6. So I'm going to say 7/3 x is equal to, well, I need to multiply the top and the bottom of this first fraction by a 2 in order to give this denominator a 6. And we need to multiply this fraction, the top and the bottom, by a 3 in order to give this denominator a 6. So now I'm going to say 2 times a negative 2 all over 3. 2 times 3 plus 3 times 5 all over 3 times 2. Okay, so now we have 7/3 x is equal to a negative 4 over 6 plus 15 over 6, which means we have 7/3 x is equal to 15 minus 4, 15, 14, 13, 12, 11. So 11 over 6. And now we need to multiply both sides by the reciprocal. So the reciprocal is 3 over 7. 3 over 7. So now we have x is equal to 33 all over 6 times 7 is 42. Okay, so there we have it here. And that is actually a proper fraction, so we're good there. Sometimes your teacher will want you to convert, like I said, into a mixed number if it's not an improper fraction. If it is an improper fraction. So stay tuned for our next set of examples. Okay, this is the last set of examples where we are really stepping our game up here. So we have an equation where it is much bigger than before. So we have here 2x plus 3 is equal to 5x plus 4. We are going to apply the same concepts. So let us see what we're going to do first. Okay, so we have an x attached to the 2 here, and we have an x attached to the 5 here. You can either move the 2x on this side or the 2x on this side. Sometimes it does not matter. It does not matter, but for the sake of, I guess, being consistent, how about we move our x over here? So what we're going to do is we're going to subtract 5x from both sides. So if I subtract 5x from this side, I'm going to get a 0. And if I subtract 5x from this side, then, so 2 minus 5 is a negative 3. Be careful here. Okay? So 2x minus the 5x is a negative 3x. Okay? So let me just rewrite and clean this up. So now we have negative 3x plus 3 is equal to, remember this is a 0, so 0 plus 4. Okay? So now I'm just going to rewrite it again. Negative 3x plus 3 is equal to 4. So now I want to take and I want to bring this 3 over to this side. Okay, so I'm going to subtract both sides by 3. I get 0. If I subtract on this side, I get 1. And I'm just going to clean it up. So negative 3x is equal to 1. So now I want to isolate x. So I'm going to divide by a negative 3. Negative 3. So now the 3's cancel. A negative over a negative is a positive. So now we have x is equal to a negative 1/3. Okay, so there we have it for our first one. We're just basically combining all of our knowledge together. Let's come over here. Again, we started with the x, the numbers that were attached to the x. It doesn't matter which way you go first. Just make sure you are subtracting numbers. If a number is attached to an x, make sure that you are subtracting numbers that are attached to the x on the other side. If this one does not have an x, you want to subtract it or add it to a number that does not have an x. So be careful with that. So I guess I'll start off by just taking the one without the x over to the other side. So that means I am going to add 4/6 to both sides. So I'm just going to rewrite that out. So that's going to be negative 2/3 x plus, this becomes a 0, right? Plus 0 is equal to negative 3/4 x plus 5/12 plus 4/6. Okay, we need a common denominator here. To add these two together, the common denominator will be a 12, which means I need to multiply this fraction, the numerator and the denominator, by a 2. That's how we're going to make this denominator a 12. So if I were to go ahead and multiply the denominator and the numerator by a 2, we're going to get negative 2/3 x is equal to negative 3/4x plus 5/12 plus 8/12. Now I can go ahead and combine the numerator. So I'm just going to rewrite it. 2/3 x is equal to negative 3/4x plus 8, 9, 10, let's see, 8, 9, 10, 11, 12, 13. So that's going to give us 13/12. So now we're done with dealing with numbers that were not attached to the x. Let's now deal with the ones that are attached to the x here. So I'm going to add 3/4x to both sides. And I want to line them up because you can get confused sometimes if you don't see them I like to see them in a linear fashion. 3/4x is equal to 13/12. So this is what it looks like now, because negative 3/4 x plus 8/3 x becomes a 0. So we're just left with this part, and that's why we have it here. And then now we're saying negative 2/3 plus 3/4. Now we need a common denominator. Our common denominator is a 12 in this case. So I need to multiply the top and the bottom by a 4 over here. And I need to multiply the top and the bottom by a 3 over here. So 4 times a negative 2 is a negative 8. And 4 times 3 is 12. Keep our x. Plus 3 times 3 is 9. And 4 times 3 is 12x. And that's equal to 13/12. Okay, so now we can add the numerator. So that gives us 1/12x is equal to 13/12. We're almost done. We need to isolate x. In order to isolate x, we need to multiply by the reciprocal. So we're going to say 12/1 here, and we're going to say 12/1 here. And this means, let me draw a line here to show that we're continuing. So x is by itself, and the 12s cancel, right? So we are just left with 13. Wow. So x is equal to 13. Wow, that was a lot, wasn't it? So we can just sort of rewind the video if you need to sort of relook at it and sort of think through on what we did. We basically build on part 1 and part 2. So hopefully this helped you. Thank you for watching and have a good day. Bye-bye.